There we go. So what are we going to do with this? We want to prove that these lines are parallel. Ruby, you have an idea? Okay, yeah. Look, we could say angles 3 and angle 1 are vertical angles, right? Why is that? Just because of the definition of vertical angles. And if I don't know if you can see the sheet or not, but if you look at the sheet on there, from chapter 1, the definition of vertical angles just says that if two lines cross, I can't remember what the exact definition is, but essentially it just says that opposite angles when two lines intersect are vertical angles, right? So we know, okay, I guess they're going to go another route. That's fine. We're going to use that though, right? Angle 3 is congruent to angle 2. And there's no one right path to do this. You can mix these steps up if you want it. So we're saying angle 3 and angle 2 are congruent. What's our justification for that? Yeah, good. Corresponding angles postulate. Very good. Okay, so let's show that they're congruent. Good. Good. So angle 3 and angle 2 are congruent. Ruby had a suggestion. What about saying angle 3 and angle 1 are vertical angles? And probably they kind of skipped a step there. We probably should say angle 3 and angle 1 are vertical angles by the definition of vertical angles. And then we could say that they're congruent. Why? Because vertical angles are congruent, right? Which we call it's the vertical angles theorem. On this sheet, you'll notice that there's going to be kind of a bold, underlined title for each of these reasons and then a description of the reason. What you'll enter on the assignment is just the title is all. So we would have entered vertical angles theorem, okay? And then angle 1 is congruent to angle 2. Now, why is that? This one is maybe a little bit tricky, but this is back on the first page where it lists some of the general properties. If you look at the transitive property of congruence, real quick, look at what that says. The transitive property of congruence on page 1. If A is congruent to B and B is congruent to C, then A is congruent to C. So the transitive property, you can think of it as transferring the congruence from A to B to C, right? Oh, you didn't get one of these, did you?
Thank you.
And these are, this is on the geometry Moodle page under course resources. It's a PDF if you ever wanted to look at it or print it out. It's there. Okay, so then this would be the transitive property. Oops. And we're done, right? That's the final step. That's what we wanted to prove, is that 1 is congruent to 2. Okay, that's it. That's all there is to it. These are, like I say, I'm not going to have you guys write up a bunch of formal proofs, but I will have you fill in some blanks on these. And it's kind of like a puzzle. It's kind of fun. Don't dread it. It's not a big deal. It's nothing that's going to be a huge part of what we do. What about the transversal theorem, real quick? If we want to prove, you know what? I'm going to skip this one. We'll do this one later. This is a little bit longer. I'll skip this one. Come back to that one later. Real quick, I just want to introduce, and this is seriously 5 minutes. There's nothing to this really. Section 3.4 is just a repeat of section 3.3. The only difference is we're just going to flip around all of those statements that we made in 3.3. Remember, in 3.3 is the one we just talked about, right? Transversals and parallel lines. All of those statements, starting with the corresponding angles postulate, they always said the same thing at the beginning. If two parallel lines are cut by a transversal, then something, right? Notice these, what the difference is. The corresponding angles converse, and all the converse means in geometry is we're going to flip around the if-then statements. It just says, if two lines are cut by a transversal, so corresponding angles are congruent, then the lines are parallel. So instead of the if being the lines are parallel, it's the then part of the statement, right? So these are the converses of those original statements are the ones that we would use to prove that lines are parallel, right? Sean, this way. Right? Does that make sense? So then that's the corresponding angles converse, the alternate interior angles converse. Same as the alternate interior angles theorem, except flipped around. If two lines are cut by a transversal, so alternate interior angles are congruent, then the lines are parallel. You can kind of shorten that maybe just to say, if alternate interior angles are congruent, if alternate interior angles are congruent, then the lines are parallel, right? Okay, and then what do you suppose the consecutive interior angle converse is going to say? What do you think? If we have consecutive interior angles, real quick, right, I've got two lines cut by a transversal. Consecutive interiors would be like this angle 1 and that angle 2, right? What's the relationship between those two if these lines are parallel? Ah, good, they're supplementary, aren't they? Good. So then, doesn't that mean that the converse of that statement is going to say, if consecutive interior angles are supplementary, then the lines must be parallel, right? And so on and so forth. It just follows that same pattern. The alternate exterior angles converse. If alternate exterior angles are congruent, then the lines are parallel, right? Just the same statements as before, flipped around. So real quick, let's just look at one more quick proof. Let's look at a proof of the alternate interior angles converse. So we just want to prove that if we know angles 1 and 2, so we're given that those are congruent, can we prove that lines M and N are parallel? We want to prove, and this is something we're going to be able to use from now on, but we're going to prove it once. Okay, and remember, we can use the corresponding angles postulate as one of our reasons, because that one we don't have to prove, it's just given to us. So I guess we'll get to click through it, but does this make sense? Angles 1 and 2, oh, we don't have a picture there, do we? Oh, that's bad. Okay, we'll look at this tomorrow at the beginning of class. I'll put the picture on here. That's kind of inconvenient. The other kinds of problems you're going to do is stuff like this. Find the value of x that makes the lines parallel, right? You'll be given a situation where you've got two lines cut by a transversal, and you've got to pick the value of x that's going to make those lines parallel. Well, what kinds of angles are those two angles here? Yeah, they're good. They're consecutive interiors, right? And so they should be, in order for these two lines to be parallel, those have to be supplementary. So what does that mean in terms of an algebra equation? Well, that measure plus that measure has to equal 180. That's what supplementary means, right? So there's our equation. X plus 4x equals 180. All we have to do is solve that equation. So we combine like terms and get 5x equals 180. We divide by x, and we get x equals 36. So we know that one's 36, right? The small one, and then the big one would be 4 times 36, which is 144. Okay? So if those angles have those measures, then, or if x has the value 36, then that works. They're supplementary. Okay? Real quick, decide which rays are parallel. Are rays EB and HD, are those parallel? They're not, are they? Now, sometimes it's helpful in situations like this. This is a good little trick. It's no big deal. But sometimes it's helpful to extend those rays so they look like lines instead of rays, right? And if it works for the ray, it's going to work for the line because the ray is contained inside the line. So look how much better this looks if I take those rays and I do that. Now it looks like two lines cut by a transversal, right? And now we can see those relationships maybe a little bit better. So if the red lines are the two lines that are cut by the green transversal, how would you describe the 58-degree angle and the 61-degree angle? Yeah, they're corresponding, aren't they, right? Those are corresponding angles, and in order for the red lines to be congruent, what would have to be the relationship between the corresponding angles? They'd have to be, yeah, the measures would have to be equal, wouldn't they? And they're not. So the red ones are not parallel, are they? Well, what about, let's extend maybe these rays. Are the purple lines, and therefore the rays, congruent or parallel? How could we tell? What do you think? Carrie, you got any ideas? We gotta show the purple lines are parallel or not.
Yes,
They are, you're right. How could we tell?
because they don't intersect.
Okay, they don't, but maybe they intersect way up there or something, right? We gotta look at the angles. Is there a way, because the red ones don't look like they intersect either, but they would, because those angles aren't, the corresponding angles aren't congruent, right? What can we do here, though? What do you think? Good. Okay, so if we add these up, 62 and 58 adds up to what? 120. Okay, so then this whole measure right here, if we add up this whole thing, it's 120 degrees. What's 59 and 61? 120. Well, aren't those, the pink angles are corresponding angles, aren't they? Right? If I slide this purple line over this way, this big angle, whoops, that went too far, didn't I? I did. Well, let me fix that. That's gonna confuse you. There, how's that? So this pink angle and this pink angle would overlap completely, wouldn't they? Perfectly. So they are corresponding angles and they are congruent. And so then we know that the purple ones are parallel, right? Make sense? Okay. So those are not. 61, the angles are corresponding, but they're not congruent. So EB and HD were not, but those were, right? Because 62 plus 58 equals 59 plus 61. All right, so how can we show that two lines are parallel? We could use any of these resources. Alternate interior angles, corresponding angles, or alternate exterior angles could all be congruent, or consecutive interiors could be supplementary, right? Any of those relationships prove the lines are parallel. All right, got a couple assignments up. You should have tons of stuff to work on. Grab a Chromebook and go.
Yeah,